Its many lines of symmetry make a circle a special kind of an ellipse. In general, an ellipse has only two lines of symmetry. Example problem 2. Graphing an ellipse. What is the graph of 9x squared plus 16y squared equals 144? What are its lines of symmetry? What are the domain and range? Well, we would graph an ellipse in a very similar fashion to the way we graphed a circle on example problem 1. We would either use some form of graphing utility or software, or make a table of values, and then use what we know about symmetry to fill in the rest of the graph. After constructing the graph, well, we would take note of the elements needed to answer the question. The graph is an ellipse. The center is the origin. The ellipse has two lines of symmetry, the x-axis and the y-axis. The domain is the set of real numbers x with -4 is less than or equal to x, which is less than or equal to +4. The range is the set of real numbers y with -3 is less than or equal to y, which is less than or equal to 3. And a chance to show that you have got it. What is the graph of 2x squared plus y squared equals 18? What are its lines of symmetry? What are the domain and range? Not all conic sections consist of one smooth curve. The hyperbola, for example, consists of two separate curves called branches. Example problem 3. Graphing a hyperbola. What is the graph of x squared minus y squared equals 9? What are its lines of symmetry? What are the domain and range? Well, again, we'd start by making a table of values, and we would substitute in points that we'd like to work with for x to see what y's are associated with those. But perhaps first we would like to have our equation solved for y. Substituting in -3, -3 squared is 9, 9 minus 9 is 0. -2 substituted in for x. -2 squared is 4, 4 minus 9 is -5, and the square root of -5 is not a real number. Notice this number doesn't have a home on our coordinate plane. So our function is not defined for the input value of -2. How about -1? -1 squared, 1 minus 9, -8? No, square root of -8, not defined on our coordinate plane, which simply means that -2 and -1 so far are not values of our domain. 0, note the same thing. 1, 2, 3, 3 squared is 9, 9 minus 9 is 0, and the square root of 0 is 0. Alright, so let's consider that we were graphing this on our own. So far, we don't have much information to form a graph. Certainly not the graph of a conic section. We have the points -3, 0, and 3, 0. So let's just use the coordinate plane given to us in the problem, but assume that we can't see the color red. At this point in our work, all that we have are these 2 points. Not enough for a graph. We've also learned that our graph is not defined for values between -3 and +3 on our domain. So we should plug in new values, values outside of -3 and +3. So we'll move on and try -4 and +4. The graph is a hyperbola that consists of 2 branches. Its center is the origin. It has two lines of symmetry, the x-axis and the y-axis. The domain is the set of real numbers x with x is less than or equal to -3. Note that means x is to the left of, on our coordinate plane, -3, or x is greater than or equal to +3, so to the right of +3, but not in between. The range is the set of real numbers, so note our graph assumes all real numbers in terms of its y values. And a chance to show that you have got it. What is the graph of x squared minus y squared equals 16? What are its lines of symmetry? What are the domain and range?